Jai Hind everyone, myself Ankita, faculty of Department of IT, AKGEC. Today I am going to discuss convolutional neural network of MLT Unit 4 BCS 055 code. So what is convolutional neural network? So we also call it as CNN. Now it is a deep learning technique which is used to which is designed for processing and analyzing the image data, imaginary data like images, videos, and in some cases linear data, that is your audio and text. So we are using the CNN for basically identifying the various images, digital images or videos. Now the application of CNN lies in your image classification, object detection and segmentation. Now image classification means that we are trying to identify whether the image is like, for example, is an apple or a banana, right? So we are just classifying the images by identifying the object in it, right? Object detection means that we are trying to identify the different objects that are present in a image, right? For example, I have a road scene and I have to identify where are the vehicles, where is the road, where is the pedestrian. So that comes in your object detection. And segmentation means that we want to identify the value of each pixel, that what this pixel represents, right? So these are the various applications of CNN. Now prior to CNN, we used to have manual feature detection, in which we used to manually extract the features from an image and then we have to find out what image is that. Now that was very cumbersome process and it took amount lot of time. So now we are using CNN. So basically when we talk about the image, how a computer read an image. For example, I have an image. Now as you know, that image is represented as an array of pixels. Now we have a pixels, and for each pixels we have three values, R, G, B. So basically an image is converted into a 3D array of values, right? Representing the pixel values of R, G and B. So this is how we represent an image in a computer. Now when we talk about traditional methods of image identification, what we used to do, suppose we represented an image as an array of pixels. Now it is a 2D array of pixels. Now here, for the sake of simplicity, I am using 1 for the presence of pixel, that is and for -1 for the absence, right? Now in reality we have a values corresponding to RGB values. Now for simplicity I am using 1. So if the pixel is lightened, I have put 1, otherwise I have put -1, right? Now when I am depicting an image, and this is a handwritten number 9, I am trying to depict or identify which number is it, right? Now I have depicted it in a pixel form like this, right? So the pixels are eliminated where there is a presence of image, right? So I can train my computer that if this is the arrangement of pixel alignment, we can say this number is 9, right? Now the problem with this is that we have hard coded the pixel values and pixel positions. Now for example, if my handwritten 9 shifted to left, so its corresponding pixel values will be like this. Now it won't match with the trained 9, right? So here in this picture and this picture is not matching. So obviously my system won't be able to find out that this number is also 9, though location has been shifted. Similarly, if I have written 9 like this, now the pixel values will look like this in the image. Now this also is not matching with your trained information, that I have told the computer that this is my 9 number and this is the image I have received. Now this image is not matching with this image. So this process is very hard coded. Now the next thing that we tried to use was artificial neural network to identify variety of digits. So my ANN model was able to identify different varieties of 9. How it was done? Suppose that this is my image, suppose this is my image 2, and I have converted them into a grid of numbers. Now I have used 7 by 7 grid. Now mind us that we are using the normal neural network, artificial neural network, to identify this handwritten 2. Okay. Now what we do, we flatten. Now I have to feed this image into my neural network. For that I need to flatten this matrix. Now to flatten this matrix, I have around 49 values in this. To to analyze these 49 values, I should be having 49 neurons in my input layer and corresponding 49 neurons in my hidden layer. Okay, and since my output is consist of only number from 0 to 9, so my output layer will have 9 neurons. Okay, now you can imagine if every of these neurons are connected to all of the neurons in hidden layer, I have to train as many as 49 into 49, that is 2401 parameters. So to train this model, I have to find out the values of these 2401 parameters. Similarly, in this area, I will have to find out the values of 490 weights. So weights or parameter are same. So I have to find out the values of 490. Now this is very huge number of parameters for identifying such a small number 2. Okay. So imagine if I have a proper image, right, of a cat or a dog, how much number of parameters I need to train. It will be in millions and billions, right? So this process is also very much lengthy and cumbersome. So here we are having too much computation, and also the problem of local pixels and far apart pixels, they treat them as same. Also it is sensitive to location. So if my in my training I have put that position number 9 over here, and in my testing my number 9 is here, it won't be able to identify that these two images are same or not. It will identify that these two images are different. So this was a problem of your artificial neural network. So to solve these problems, we have started using your convolutional neural network or CNN. Now here the CNN compares image pieces by pieces. So it follows the same approach as we try to identify anything, right? Suppose I have seen a picture. Okay, so how will we identify what picture is it of, right? So I will try to find out the eyes, then nose, then mouth and face, and then the body. So with individual features, I will try to find out that which image is that of which type of object that image is, right? In the same manner, CNN tries to break an image into subparts. So it first tries to identify the subpart of the images and then join together to identify the whole image. For example, if it has to identify 9, so what it will do, it will break that 9 into various parts. So if I am trained to identify 9, so what I will do first, I will be trained to identify the subparts like this. Okay, I will break this image into different parts. Okay, like this. Okay, and then for each part, I will first identify these subparts, and then I will combine them. Suppose these 3 combine to form a loop, these 2 combine to form a vertical line, and this combine to form a diagonal. So in different layers, in first layers, I will be identifying these. In second layer, I will be combining the values of these, and I will be identifying the major features. And at the end, I will be identifying the major number 9. Now in CNN, we have 3 layers. First is your convolutional layers, pooling layer and fully connected layer. So we can have many convolutional layers and many number of pooling layers. So what is the need of these 3 layers? We will be discussing one by one. Now convolutional layer is the core building block of CNN, and it is where the majority of computation occurs. So major computation occurs in your convolution layer, and mind you, we can have multiple convolution layers according to our need. Right. So here we apply convolution operation to extract the features from the input data. The purpose of convolution layer is to identify the features in your image. So whatever image that I received, I will have to identify various features from that image, and then I have to match whether these features are matching with my image or not. Okay. So here we have majorly 3 components. First is your input data. Then I have a filter, and then I have a feature map. So basically input is nothing, it is just a matrix of pixels, RGB pixels in 3D, right? This is my input. Filter is what? Now filter depicts a feature that we are trying to identify in an image. So this filter will move across the whole image, and wherever that filter, that feature is present, that filter will tell you yes. So you can say in summary, we have we first divide an image to be identified into multiple features, right? Then for each feature, we make a filter. Okay. Now, whatever image that we need to identify, we apply that filter on that new image, right? To find out whether this image is what. Okay. And then this process of applying filter to an image is known as convolution. So, mainly the filter is also known as feature detector, is a two-dimensional array which represent the part of the image. So, we can say, suppose this is my image. Okay. Now, I am representing that image into an pixel values. So, like this. Okay. Now, I have to identify this image. Okay. I know that this image is of 9 and I have to identify this image. So, from the set of images that I have. Okay. So, what I will do, I will try to identify what filters can I make of it. So, I can make a loopy filter. So, this will be my one filter. Now, another, I will make a straight line filter, like vertical filter from this, and I will make a diagonal line filter. So, like this, I will be having 3 filters to identify an image 9. Okay. What I will do, now this is my filter. Okay. I am representing, this is my filter, loopy filter, this is my loopy filter, and this is my image that is input given to me. Okay. So, what I will do, I will make a dot product of this filter with this first portion. Now this is 3 by 3 filter. We usually make a filter of 3 by 3 only, right? So, what I will do, I will apply this filter on this portion. Okay. I have to apply this filter to the entire image from the beginning. I will apply the filter in this portion. Okay. So, how will I apply this filter on this portion? By making dot product. So, I have done dot product. 1 multiplied by -1 plus 1 plus 1 plus 1 plus 1. So, for each of these values, I will do the dot product and I will multiply these values and I will get a value -0.11. So, I have got the value as -0.11. For this, then what I will do, I have to apply this filter to the entire image. So, what I can do, I will make a stride. Now, stride is how much I will move further. So, I can have a stride of 1 or 2 or 3. So, if my stride is 1, I will move 1 step. So, now I will apply the filter on this position. If my stride is 2, then I will have moved like this. For every step, I will move 2. Now, here my stride is 1, so I have moved over this. Okay. Now, what I will do, again, same process, I will make a filter and I will make a dot product with this portion and I will get the value as 1. So, similarly, for all this filter is moved across the image doing the dot product and stride of 1, I have got a feature map. Now, this is the third component that I received from your convolution layer, that this is my feature map that I got by applying loopy pattern detector or filter on my image. How I apply my loopy filter? By doing the dot product. So, this is my 3 by 3 image and this is my 5 by 5 image. So, what I will do? This is my 6 by 5 image. So, what I will do? I will just use this and multiply with this. Then first I will multiply by this, then with this, then with this. Again, stride of 1, this. So, like this, I will keep doing. At the end, I will receive a feature map which look like this. Now, this is my convolution layer. So, if I have a loopy pattern detector, what I will do, if I apply my loopy pattern detector on this image, I will get 1 over here, right? So, whenever loop is present, wherever the place a loop is present, I will get 1. So, here the loop is present at the top, I will get 1 over here. Here the loop is present at the bottom, so I will get 1 here. If here the loop is present at the 2 points, so I will get 1 twice. So, this is how we are getting to know where that filter is present in my image, right? So, here I am able to identify subpoints. So, in case of loopy pattern detector, I observed that 1 is over here. It means the loop is present at this position. I applied vertical line detector. I got 1 over here. It means the 1 is positioned. This vertical line is present at this position of the image. And for diagonal line, I received 1 over here. It means this this pattern is available at this position. So by this we got around 3 feature maps. Okay. So when we receive this feature map, we move on to next layer known as ReLU layer. Now ReLU is nothing but it is an activation function which is used to apply the non-linearity to the image. So what does ReLU means? It is just rectified linear in unit. It says that if my value is less than 0, I will output 0, and if it is greater than 0, I will output whatever value I have got. So for this, what happens? This is my feature map that I obtained after applying the convolution layer. And what I will do, these negative values will be put to 0 by applying ReLU function. So here you will say, earlier my function was like this. Okay. Earlier my function was like this. Now my function is like this. So here I have observed a non-linearity. So here 1 is present and this minus 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 all is gone to 0. Okay. So that is how ReLU is used to make the model non-linear. Now next layer is your pooling layer. So first one was your convolution layer. In convolution layer, what we did, we applied filters on my image to identify various features in my image. Okay. After that, we have applied ReLU function to introduce non-linearity in my image, right? And then what next layer is your pooling layer. What does pooling means? Pooling is used to downsample or reduce the dimensionalities. Now my size of my matrix is very huge. So what I will want that I have to reduce the size so as to reduce the computation, right? So in pooling layer, we tries to reduce the dimensions. So similar to convolution layer, the pooling operation sweeps a filter across entire input, but difference is that this filter does not have any weights. So what does it mean? That here also we apply a filter to the entire matrix, but in that matrix we don't have any value. In that filter we don't have any value. So how we do pooling is, there are two ways. One is max pooling, where we move the filter across the image and we find out the maximum value in that filter, in that area. Okay. So we write that value. And in case of average, what we do, we take the average of all the pixel values. So that is how it is done. For example, now this is by applying loopy pattern filter, I got this image. Then I applied ReLU function, I got this, right? 1. And all the negative values have been put to 0. Now in max pooling, what it will do, we will make a 2x2 filter and I will see over here. Okay. And I am applying max pooling. So here the maximum value is 1. So I will put 1 over here. Now in next, here the maximum value is again 1. I will put 1 over here. Then next, here the maximum value is 0.33. So I will put 0.33 over here. Then again next, 0.33. So similarly, we will apply max pooling to the entire image and we will receive this as a number. So what is the benefit of pooling? It reduces the dimensions and computation. It has reduced the size of my matrix. So obviously, when the size of my matrix is reduced, when I will flatten my matrix to a linear array, obviously the value will be lesser. Also, it reduces overfitting as there are less parameters. Obviously, when my size is reduced, dimension is reduced, my number of parameters will also be lesser, and hence it will reduce the overfitting. Model is to learn towards variation and distortion. So here, irrespective of the positions, why? Because I have been identifying the features. So obviously, if it is in any position or it is in any variation, I will still be able to identify that number. Next layer is your fully connected layer. Now it is same as your artificial neural network. Now here, each node in the output layer connects directly to a node in the previous layer. Now this is also, it is same as that of your artificial neural network. So this is the last layer. After identifying the individual features and then reducing the size of the image, I am again applying the fully connected layer. So this layer performs the actual task of classification based on the features extracted through previous layers and their different filters. So we have applied different filters, and then after applying different filters, what we have identified the features, and after identifying the features, what we have done, we have reduce the size, and then after reducing size, I have to find which number is it. I have identified the features and I have to identify which number it is. We do in the fully connected layer. So here every layer, previous layer neuron is connected to every neuron in this fully connected layer. So here in convolution and pooling layers, we used to apply an activation function called as ReLU. Whereas in your fully connected layer, we apply a softmax activation function which appropriately produce a probability from 0 to 1, whether the number is 1 or which number is it, right? For example, if I have given the input image as this, I will do convolution plus ReLU. In this, I will identify various features, right? Then I will do pooling. In pooling, my size will be reduced, and then again, there could be many combinations of convolution and pooling layers. So I have various combination of convolution and pooling layers. So once my all features have been identified and the size is also reduced, I might flatten the error, right? When I flatten the matrix into an array, and I will feed that into my normal neural network, which is known as fully connected neural network. And then at the end, I will be able to find out whether the number is 9 or not, right? So this is a very simple way by which we can use convolutional neural network to identify the numbers. So there are many algorithms that are based on this CNN, which has been used in identifying various images, right? So that's all for now. Thank you.